Hello guys, I got another physics problem from you. So this one I believe is going to be really, really important. Whenever you're getting ready for physics in college, it's always going to be usually general physics 1. It's going to be the first class after college algebra. You betcha that this could be your midterm, especially if you're going to be taking a summer class where it's about 8 weeks long. Especially this problem. Let's see here if we can go over this problem. It's right around here. So if I remember correctly, it's going to be involving a helicopter is rising constantly at a velocity of 10 meters per second. When the helicopter is at 75 meters above the ground, a passenger accidentally drops her camera out of the window on the helicopter. Ignore air resistance, where a numerical value is necessary to take the acceleration of 10 meters squared. So usually when we get a problem like this, we're going to be associated with 3 questions. Some of the questions we're going to go over, so if you don't see them right now, that's perfectly okay. But what I want everybody to get in the habit is actually visually seeing that a helicopter, as you recall, is going to be what they would say rising. So when we're going to say rising, we're going to say V initial. At 75 meters, they said a passenger drops a camera. So I guess we can get that camera right around here and calculate 75 meters. Now, they're saying gravity is going to be 10 meters second squared. So we know gravity already is going to be not a positive number. That's one thing you guys got to remember too. There's 2 gravities now. Gravity is actually going to be what I like to consider negative 9.81 meters second squared. No easy way to remember it. Try to remember it the best you can. 9.81 meters second squared. Here we're using the rounding number. Remember, gravity is always negative. Tip note, when dealing with energy joules, try to think it's positive. Let's go ahead and see if we can come up with a proper, what I like to call 3 questions associated. So the first question is going to be is calculate the max height. So for max height, we're going to have to utilize kinematic equation of velocity squared equals v initial squared plus 2a delta x. Let's go ahead and bring that over here. V squared equals v initial squared plus 2a delta x. Let's go ahead and minus v initial squared. And then we're going to get v squared minus v initial squared equals 2a delta x. Let's go ahead and take that 2a and divide it. So what I would like to see left with is a v squared minus v initial squared, 2a delta x. Go ahead and turn that into a delta y, v squared minus v initial squared all over 2g. So from there, we're going to go ahead and plug in the numbers associated. So this is going to be the formula right here that we're working with. Delta y equals v squared minus v initial squared 2g. So let's go ahead and plug in the numbers that we already know. So the velocity is going to be 10 meters squared. So we're going to start right over here, and we're going to go ahead and decide to use 10 squared. Remember, v final is going to be 0. So the impact 0 is going to be flat, no more. 10 squared all over 2g. Now, 10 squared is going to be 100 squared. Because we have 0 minus, it's going to be negative 100. And then we're going to have 2g. G is going to be negative 10. 2g is going to be negative 20 equals 5 meters. h1 plus h equals h max. This is going to be considered h1 plus the original distance, 75, will give you the total max 80 meters. Da, 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 da. That's going to be the first solution. Okay, here comes what I like to call the quadratic formula for the how many seconds pass. So for the quadratic formula, I'm going to go and give you my specialty right now. S equals half a squared t squared plus bot plus yo. A squared, b squared, c squared. Here comes the quadratic formula. This is the way I remember it. Negative b plus minus square root b squared minus 4ac all over 2a. Now try to plug in what you know. So to make life easier, I can go ahead and let's do it this way too. A equals b equals c equals. So A is going to be half a g, b is going to be the velocity, which is going to be 10, and c is going to be the distance. And we're going to go ahead and use the total distance, 80 meters for this one. So if we were to use the quadratic formula and plug in what we know, we're going to see negative 10 plus minus 10 squared minus 4ac r over 2 half g. And then we're going to go ahead and try to make life less complicated by trying to make this more simpler. 10 squared is going to be 100. Minus 4a. 4a is going to be 5. So we're going to have 20 and that's going to be a negative. And now C, I'm going to give you guys the 80 right here. So this return, we're going to have to figure out when we got 4A to 20, 80, that's going to be, we like to call it negative 1600 minus the 100, which is going to get you, well, I considered 1700 ton all over negative ton. Square root of 1700 is going to be what I like to call 41.23 ton plus or minus negative ton. And this is going to be one more step closer. Okay, so negative 10 plus 31 is going to be 31 positive plus negative 10 will get you a negative 3.12. Negative 10 subtract 41 is going to give you negative 51. Negative 51 divided by 10 is going to give you 5.12 seconds. Here, we can go ahead and find the distance. Distance is going to be v squared equals v initial squared plus 2a delta x. If you need to, we're using this one right now for distance, for velocity, excuse me. Plug in what we know, 10 squared, plus 2 gravity, which will give you negative 10, plus, I like to call it 80 right here. 10 squared is 100. Negative 10 plus 10 is going to be, let's say, negative 800. Negative 800, let's be positive now. So negative 10 times negative 80 gets you positive 800, which you positive 1600. Take this, combine together, you're going to get 1700. Square root it. You should be left with velocity equals 41.23 meters second squared. Remember, only gravity is going to have the meter second squared. Only gravity you're going to see with that one. So make sure you get this one, understand this one. This is going to be what you like to consider a physics hot one, physics midterm important one. Expect to see this too on your midterm as well in General Physics 1. Thank you.